checks that again and SHA-1s it and checks that this wasn't entirely made of lies, basically. Well, but I'll talk about it in a minute. Hardware is made of lies. And the reason this is split into a load of processes is that things work at separate rates. So, one day downloading can be slow because the network is screwed, and one day encoding can be slow, and you run several encoders. And so basically you have one mode that tries and keeps 20 files to be encoded here always, and you have one thing that tries to keep no files to be uploaded always, and then the encoders can just work through it at whatever speed they can work through it. And if they never work through that, then the web service kind of resets things that have been checked out after a while, etc. It works quite well. So while I'm on the hating, soap. Who's heard of soap? Good. It stands for snakes on play. No, seriously. So we're using SoapLite, and we control both ends, and we're using an old version of SoapLite that happened to work for us at the time that I don't want to touch because it's all available, and it works. And that's the best thing I've got to say about it. Don't ever try talking to anybody else. Or more specifically, if you have to consume someone else's soap service, then kill yourself now. If you provide a soap service for someone else, oh, dude. No, use Java. No, seriously, SOAP servers in dynamic languages do not work because we have all this flexible typing stuff that is really nice, that is why we use a dynamic language. It doesn't work if you're talking to a Java client. It doesn't work through SOAP. SOAP servers to interoperate, use C# or Java. Yes, I know. Yeah, you're about to say XML compile does this a lot better than
it's great.
Yes.
It shouldn't break.
Yes. No. There are better ways to do this than SoapLite. It is. No. There are. If you have to put up with this pain in Perl, don't use SoapLite. Do XML compile. But if you're being the server end, don't be a SOAP server. Just unless you have to, don't. Is all I'm saying. If you have to be a SOAP server, then yes, excellent XML compile. Thank you for that. Don't be a SOAP server. Just don't do SOAP. It's snakes on a fucking plane. What else can I say? No, document literal's a lot better. Yeah, there are ways to make it less bad, but the best it gets is less bad. Okay, so logging. So go back to my diagram. This process, and this process, and this process, and this process, and these two web services, and all of these HTTP nodes, and debugging that is fucking amazing. When I say amazing, I mean really, really easy. No way, you're So actually, we just shove everything into syslog. And Splunk is amazing. I mean, if you have a large amount of log data, then it gets very expensive very, very fast. But the free version will consume a very reasonable amount of logs from a lot of hosts. It gives you this lovely aggregate view, and you can just type queries in and search back through your entire log history. So it's really nice. I recommend checking out Splunk, and you just feed logs into it, and it can structure after the fact. You just feed it lines of data, and then give it regexes, and it pulls things out, which is fairly handy when you want to work out why this thing last Tuesday failed. Or more, you work out that something failed and has been cracking all over data, and by looking for this specific thing in these logs that you correlate with these three machines, you can work out all the times when you've shit on someone's data. Doing that yourself is not so fun. After the fact, everybody's written a script to grep a million log files and do stuff, and I'm kind of bored of that. So we use Splunk. It works mostly works really well. Okay, hardware is crap. I'm clearly a hater, but hardware shit. I was at the Postgres conference the other week, 6 weeks ago, 2 months ago, and I was talking to the Greenthorn guys who have the largest production database in the world, which is over a petabyte in size. Petabyte of database. And so they have queries that you will fail 1.3 machines while this query runs. Statistically, 1.3 of your machines will fail whilst executing this query. And you have to deal with that. So I know, statistically, that And I have all these files I have 2 distinct copies of. I have 5 of them where I have an undetected 1-bit error. Statistically, and that's just from the magnetic media error rate. That's not counting the fact that networks are shit, and operations are shit, and everything's shit. So yeah, you're screwed. I mean, when you have 200 terabytes of storage, you're entirely screwed all the time. Everything's going to fail. It's all going to fail to work. You need to show on everything all the time, but you can't do that because you can't serve people files of 10 gigabytes a second and show one at the same time. Interesting problem. Yeah. Okay. So, if you need reliability, and that's the important bit. If you need reliability, and maybe you don't. Maybe you don't need the reliability. Maybe you don't need the scalability. If you don't bother. Don't even bother thinking about it. If you're going to, you need to be thinking about it before you even start it. So, yeah. You'll have a lot of product failures, a lot of software failures. You'll see awesome things like 1 stepping level, 1 CPU. When you encode media that's like this, has a specific bug, and so yeah, I'm just not going to talk about networks at all. Yeah. Included name. It's called a network. That's right. Next. Okay, so queuing things. I have the media and I'm transcoding it, and yeah, so you stuff your queue in a database, and yeah, don't do this. So here's how I fail, or here's how MySQL fails. Who has thought about how to write a database engine before? Just me. Who's thought about how you might possibly architect something that joins data? I mean, right, so let's cover this the easy way. I have a table, A, and I'd like to join it to table B. So what I'm going to do is go through every single row of table A, and connect every single possible row of table B, and that's my full outer join. And, okay, so I connected to table C by looping for every single row that I've got. And that's called a nested loop join. It works really well. No, hang on, it doesn't work really well at all. That's the only type of join MySQL has. And MySQL stats, so you want to know, I mean, you have some tables and a complex query, and clearly you can do this the right way, or the wrong way, or the really, really wrong way. By what order you join things in, because at all points you want the most selective thing possible, because then you'll join things in the order that involves going through the least data. MySQL statistics, it knows the cardinality of your columns, the cardinality being how many different values are occurring in them. So this is a massively awesome way to completely screw yourself. So we have this table called file transforms that has every single thing we've ever encoded from A to B. And it has a column called status, which has like 4 values. And it has a column called transform step, so from dirty WAV to clean WAV, or from clean WAV to MP3. We have a lot more possible different transforms from A to B than we do statuses. So the MySQL query planner, the correct thing to do when you're asking a query is to find every single thing with this status. Yeah, and so I end up finding every single video made by end of night, and then find the ones that I want to encode. But I don't, because you say that. But this is a query that I end up executing, and this is Tango Plastam. And yeah, putting false index in there makes it do the right thing. And actually, when you look at it, it couldn't possibly do a better thing because it's too stupid to know how to do it right. From the information MySQL has, it's doing it right, but it doesn't. Don't use MySQL. No, Postgres is also relatively, I mean, software still, but Postgres is awesome. Okay, so yeah. Sorry?
Why didn't you switch?
Because I'll ask that at the end if I haven't got it. Okay, so yeah. Find everything that ever led to WMA, a million things. Join it to every file we've ever made, millions of things, and that's going to work not so good. Because yeah, you end up with 1 million times 1 million, or 2 million times 2 million operations, and this query takes a while without the false index. In a kind of 10 seconds versus 30 minutes away. Awesome. Did I mention queues in the database suck? And even if you're not screwing it up, like we managed to entirely screw it up, than just suck. Get a message queue, or quite a lot of people for their message queue just want a job suck. So Gearman is great. It works really nicely. I mean, if they're just kind of simple job queuing, we'll use that. If you really need a proper message queue or interoperability, I'd say RabbitMQ. The Apache ActiveMQ stuff is really good, as long as you don't ever have 10,000 messages, in which case it ships itself and crashes. Okay. Talking about more things we do, so have done wrong. Mutable state is the enemy. Whoever thought that read-write accessors in class accessor was a good idea was insane. And people, so you end up with this object that has some state, and that's all I can say. It has some state. Yeah, and mostly it's in the state. Well, one of those. So this is an antipattern. The anemic domain model is its official name, and so this is a quote from Wikipedia from someone much cleverer than me, and I highlighted the important bits for me. Data, their interactions. So objects talk to objects, and together they make stuff happen. And the way this works is you have data abstraction and encapsulation and modularity. So you can take an object out and replace it, and no one will notice. Except if all your objects reach inside your other objects, and you have scripts that smash objects, and everything's rewrite, and everything knows about everything else, then this doesn't work so well, because you can't take an object out and replace it with a differently implemented object. So you want abstraction and encapsulation. This is why you're writing OO software. If you're not writing OO software, that's fair enough, because I am. Okay, so yeah, you can create valid objects, and you can make objects that used to be valid. All your actions are read-write, remember? You can just go and fiddle with someone's guts. That's fine, isn't it? No, it's not fine, because you just end up confused. I mean, I'm bad enough at programming, and that's going to be worse at debugging. And when you have all these objects that got in some state, somehow, maybe, it's really hard to debug. If all your objects, everything is read-only, then you do a data dumper and you know that these objects were created like this. If they're all read-write, then you know that they were like that when you dump them or not. That doesn't mean anything. Okay, so even better, let's put half our business logic in scripts that gets some objects and smashes them a bit and passes them. No, it doesn't pass them to someone, it gets some other objects and yeah. So rather than the objects interacting and talking to each other, let's put all the logic in the scripts that can manipulate objects. Because, objects don't need logic, they just data containers, right? I mean, just West hash. You're doing OO wrong. Sorry. Yes, and you have to employ people to run screen sessions. And yeah, employing people who are non-technical to run scripts and screen sessions is a fail. I'd just like to say that's an epic fucking fail. Okay, so something better. Going back to message queuing, we're moving to a job-based approach. So you send something over the wire, and a job server takes it and runs it, and outputs some state, etc. And none of this needs to hit the database until you have a final set of results. Or the jobs in each work in the database, but all of the kind of messaging and routing doesn't need to hit the database. And as you've got messaging, you can talk to multiple people. So you can do a hit from your web application and send a message back to the web application, but also send a message to something else and log a message and you get all of these nice properties by using messaging rather than doing it yourself or not having people do it. One of my examples is people upload spreadsheets to a website, and the spreadsheet might have 1 million lines in it, and they quite often have 10,000 lines. So you need to validate that all those 10,000 lines are right, and you need to do a load of work from that. And you need to tell them the results in the website.